tomorrow decreasing more temperature. Good evening, everyone. Okay, guys, we have only 2 weeks, and that's it. Let me ask a question. Do you receive the email with the review package? Yes or no? Yes. Okay, good, very good. Perfect. You print out. Good, very good. Don't worry. We have time to solve any question one by one. And we're discussing until you are sure that you understand very well. Okay, guys, we start the new part. Is very, very interesting in my opinion. No? In my opinion, Rosalinda start call. Okay, Rosalinda. Okay, do you see the whiteboard now or not yet? Not yet? Let me see, sharing, whiteboard, start sharing. Do you see or no? Do you see? Okay, good, very good. Okay, listen to me. Basically, today we are discussing application problem in which somehow we need to apply exponential equation or logarithmic equation. So word problem. So basically we have several, but we study only 3 kind of problem. The first one is a growth population. So this is the idea is model the population of the small organism like a bacteria, virus. It may be another a little bit big like a rabbit, a nice something, right? In which the supposition is that the population increasing exponential. So like that, look, let me show you. The supposition is this is the axis of time. This is T is time. So no X and Y, the classical. This is word problems, and this is time. And this is the amount of the organism. Okay? Maybe bacteria, maybe virus, maybe insect. Rabbit, nice. Okay, so suppose you have initial. P null. P null represent initial population. Initial population. Suppose at the beginning, well, we have 500 cucaracha, 500 rabbit, okay? Now increasing exponential like that. Ooh, you remember the exponential graph? Is like that. But in this case, have no sense in the negative part. The negative part in the word problem, no, because the time never is negative. The time increasing is only forward positive. And this is the exponential, right? And those say, what is the formula? Well, we have several formulas, but the most popular formula is population at any time, for example, here, at any time, and this is the population in this specific time, population at any time is equal the P null, que is the initial population, multiplication by exponential, but using the Euler constant, KT. I want to explain why everyone using Euler constant, because it's comfortable. Well, for several reasons. Reason number one, because we can put it directly in the calculator, in any calculator. But I want you to, P null is the initial population. P of T, of course, is a population at any time. And sorry, K is important. It's similar to the interest, but in suppose biology problem or is no interest, is the technical name is the in this case growth, because it's increasing, growth rate parameter. Okay, because actually we have a family of the exponential. Okay, one. Suppose this is so this number determine what exactly you select what exponential you try for the blue one. Entonces you say, bueno, professor, what is the reason que you use the E? Because in the problem we studied before, maybe we use in base 2, no? 2 to the x or 3 to the x. Now, what is the reason that you change to the e to the x? Well, the problem is it's possible to do it in any way. However, in our calculator, we have this. We have a calculator. Entonces, what is the conversion? What is the conversion between any base to the e base? Well, the conversion is, look, you take advantage this property, you know? For example, one number 8 is equal e to the natural logarithm of a. Remember, exponential and logarithm is inverse function. And when you apply both simultaneously in like composition on those each other, so basically the thing that we are doing is you cancel out this and this, and a is equal a. But no, we don't cancel out by using this. Suppose you have arbitrary base 2, 3, 4, 5 raised to the x power. So this is equivalent to say this is to the x power. And then you multiply the exponent to the e to the x times ln of a to the x. This you multiply the exponent, multiply this number times this number. Entonces you compare. Now you see this is e to the natural logarithm of a raised to the x power. Do you put x power here? Well, it's okay. I put it here. You assume que this guy is k. Entonces es e to the k is equal e. Forget about this kx. So we can find perfectly equivalence in between any base, no necessarily standard, and the base e gets standard. So normally the people prefer solving the word problem using exponential with the e base. Okay, it's standard. Okay, so this is my formula, my famous formula I want to use in two problems. We are doing two problems of the exponential growth population 2. This is exponential growth when the population increasing. And this is valid. This model is not realistic. It's a little bit ideal because this is valid when you have enough space in the experiment. The space, no problem. And we have enough of food for the animal. Okay, suppose bacteria is too super small, virus is super small. The space is no problem in this universal, in this planet. However, the human being, okay, this is completely wrong to say that the population of the human being increasing exponential because we have no enough space to increase. So we have no problem with the space. We have no problem with the food in the small organism, but in the human being, no? Obviously, it's not exponential. It's another mathematical law. Okay, more complicated. Okay, so let's to this problem. I copy here for you. We are talking about in this word problem about the insect. A certain insect population growth according to the of uninhibited growth, because I suppose it's a small organism. Initial amount of the insect was 500 and grow up 611 in 10 days. How many insects have in a month? Okay. Entonces, my formula is population at any time is equal P null E to the KT. P null is initial and K is the rate growth or growth rate parameter. And T is the time. The population. In this case, we are talking about insect. Entonces es obvio que P null es 500, ¿no? because the initial amount is 500. So my equation is reduced like that. P of any time in our specific problem is 500 e to the kt. The problem is I don't know k. Okay, for this reason, the problem give me one condition. But let me try to understand the problem first. Okay, in my mind, I make a graph always to understand the problem. This is population at any time. This is t equals 0, que es now. In this moment, we have 500 in set. I know que the population increasing exponential. No linear, it's no line, it's exponential. Que you remember que exponential increasing too fast, no? But one clue is que in 10 days, suppose that this is a time line, suppose that this is t equal 10 here, days, of course. The population is now 611 in set. And they asked me about a month. Month is 30 days, I suppose. Regular. No. So it's 20, 30. 30 days. Oh, exponential too fast. Here. This is the thing I am looking for. This high. Que es the population in 1 month, que es 30 days. But I don't have in my hand K. And K, remember, represent a family. So we have 500. Okay. But it's not enough. We have more degree of freedom to set out the exponential. We need one extra point. That is the reason that the problem give me this condition. This is a condition, let me call condition 0, que es initial, at t equals 0. This is condition 1 at t equal 10 in this case. And this is condition 2, que es the final answer. And the condition 1, the problem give me the condition 1 because I want to find k, allow us to find k. After when you have k in my hand, the problem have one second part in which you find condition 2. Okay? Let's move on. Guys, I suppose that everyone bring today calculator. Yes or no? Come on, I want to see your answer. Yes. Okay. Listen to me because I want to explain new thing in the calculator. Flora is a yes, I bring professor. Everyone have a calculator. Rosalinda bring. Who more bring? Okay. Sorry. Okay. Everyone bring. Okay. Good. I want to. Do you see my face now or no? All right. Stop sharing. No. Okay. It's important you see my face now. Do you see my face? Okay. Yes. Okay. I have my calculator. This is similar to your own calculator or no? Yes, right? Yes, okay, good. I want to teach new thing. Okay, maybe you know, but I don't know if you know or you don't know. Because this problem contains two parts or two answers. But one is partial answer. And what is the total or final answer? Okay, losing another finger. Two answers. This answer is partial answer. Okay, I don't care. This is not the final answer, no? And one final answer. You receive the credit to find the final answer, and this is a partial answer. But what's the problem? The problem is that we are working with the logarithmic and exponential normally give me irrational number. So irrational number, you know, can have a place, and this is the moment to truncate the decimal place or round your decimal place. So what's happening? In the partial answer, some students truncate the answer in 4 decimal place. Another student truncate in 5 decimal place. No truncate. No, the partial never truncate. You truncate around the final answer. And the decimal place that the problem indicate for you. 4 decimal place, 2 decimal place, or just whole number. I don't care, because basically the amount of insect is no decimal, is a whole number. It have no sense to say, I have 20.5 insect. What the hell is 0.5? No, I don't understand this. Entonces now, in order to do not round the partial answer, you can use in the memory of the calculator. So every calculator, elementary, have at least one memory. Suppose that you have, for example, 5. You have 5. Type in 5 in your calculator, 5. And you want to store this answer inside the calculator. Because it contains several decimal places. But in this case, it's just 5, because I want to explain the process to the memorization. So you press the key storage, que es STO, this key. This key, STO. This is on, above the on, STO. You press this. And when you press this, you can see the different memory that this calculator have, A, B, C, D, E. And you press enter. Entonces en the display you see que the memory A, you see que 5 is storage in the memory A. And when you call A is no A is 5. It's the number that you use. Entonces, how you retrieve the information for the memory. Okay, clear the display now? In order to get the value for the display, you can show 83. Yeah, of course, Jordan. It's exact. It's better. 83 is better. Look, you click in the same key, que es store, pero using the function in blue color, que the name is RCL. Do you see RCL in the same key? In the same key, RCL. So you press second, que my calculator is blue, RCL. Again, you see that you see the arrow of the cursor. But in the case, hey, I use the same. You press enter, boom, and you have 5 in the display. Okay, so the same key, storage, get in the number that you have in the display, current number in the display, into the memory that you select. Okay, by the way, you can select A, B, C, D, any memory. Press enter, done. When you want to recover, so I clear the display, nothing in the display. However, I have 5 inside the memory. You want to restore, you press second, the same key, you see the memory, you select the memory you want to get. That's the first one in this case, to don't complicate the thing. You press enter and you get 5. Okay, and the TI 83, look at that, 83. Exactly the same. It's better. It's better because, yeah, it's the same. Look, the problem is you put it on the calculator. Suppose this number. Arbitrary, you type in Jordan 20. Let me type it 20. Entonces, I want to store 20 inside the memory. Okay, you press the same key, stores. Look at that. This key, stores, STO. The same position after the on, STO. In white color. You press this. Immediately you see one arrow in the display, 20 arrow. And now you select any memory and you have 26 memory in this calculator, according to the letter that we have in the English alphabet. Pero you press alpha in green color, alpha. Alpha, suppose the most popular letter that we're using in the word problem is K, alpha K. Alpha K, let me see alpha K. Alpha K, K. I got it, K. Look at that. K is located in the paréntesis, open the paréntesis, pero en green color. So you press alpha, que es green, key, K, and you have in this moment 20 arrow K. You press enter, boom, bada boom. Now, in this moment, I suppose that when you call to K, K is not K, K is 20. It's the number, right? Now, let me retrieve the value of memory. Okay, I clear the display, no problema. Now I press, in this case, yellow key, yellow, the same key que es RCL, yellow function, RCL. Y I put the memory que es memory key, alpha K. I press enter, boom. The answer is 20. Okay. If you want, I write in the board the sequence of the key you need to press. You got it? Or honestly, it's important. Got it. No. Okay. Who say no? Let me see. Flora. Flora. Flora, let's do it. Let's do it now. Of course, Flora, you have this calculator, no? This? Flora, answer me. Yes, okay. Let's do the problem again. Suppose 20. Type in 20 in your calculator, Flora. Yes. Now you press that key. Second? No, sorry. You press store. And you see this store. Look, store, STO. And you can see the memory, ABC. You can navigate. You select A, you select B. No, pero no. A, just A. Press enter. Okay. Now, in memory A, we have 20. It was the number that you typed in before in the display. Okay. End the story. I finish. You clear the display. Nothing in the display. I want to get 20. Suppose the number is not 20. It's super complicated number. Because you copy a piece of paper, you lost approximation because it's irrational and contain, according to the approximation, the calculator, 19 decimal place. Not good. But you don't see 19 decimal place because the other decimal place is hiding inside the calculator. Okay, I want to retrieve. You want to retrieve, you press the same key, but you press second first. Second first, because I'm using the same key, but on the function above, que es RCL. Entonces, second RCL. You get the same picture. Memory A, I select the memory A, and the answer is 20. I got it again, right? So definitely, even if you putting off the calculator, the memory continue get the value you stored before. Okay, we use it in the partial answer. And the final, no. And the final, you copy in the piece of paper, you trunk it or round to the decimal place that they want and end the story. Okay, we come back to the whiteboard. Flora, you got it or no? Flora? Yes, sir. Okay. Go, whiteboard. Okay. So everyone working with the calculator. No, it's my pleasure, always. My satisfaction is that the student understand. Okay, look at that. This is my equation. This is my equation. But in this moment, I have no K. K, I don't know. Okay, but I'm using condition 1. In the condition 1, the population of the insect in this time, que está in days, is 611. So this is 611. The P of any time, que actually is P evaluating 10, because T is equal 10 in the condition 1, is equal 500 into the K, and the time is 10 days. And the only unknown that we have in this equation is K. This is actually exponential equation. This is actually exponential equation. And you solve for K. So you divide by 500 both sides. 500 both sides. 611 over 500 is equal e to the 10K. I want to, this is a multiplication, huh? I put the coefficients, numerical coefficients in the front. No K10. Use, it's the same equivalent, but it sound not good. Weird, sound weird. However, this is clear. Now you apply natural logarithm. What is the reason? Well, you can apply any logarithm, but in this case, it's obvious. Okay, it's better, much better, more efficiency. Apply natural logarithm because I know natural logarithm of 611 divided by 500 is equal natural logarithm of e to the 10K. But I know one more time happen, the natural logarithm and exponential cancel out. So you apply another logarithm that is non-natural, que the base is 10, LOG, for example. No, you cannot cancel out. But when the base is the same, yes, of course, you cancel out. Un dos, each other. Okay? Now this is just 10K. Okay? Now finally, solve for K divided by 10. Both sides. So K is equal, let me copy here. K is equal natural logarithm of 611 over 500 divided by 10. Okay. Suppose that this is the display of the hour calculator. How you type in that? And we are doing together. Yeah, I want to know the result. There are coincidences with my paper and your paper. Okay, you put in the calculator. Natural logarithm, LM. You know what is the natural logarithm? LM? You type in. Clear the display. LM. LN, immediately you press this, you put LN and open parentheses. Inside the parentheses, 611. Division, 500. Close the parentheses. 611, division, 500. Close the parentheses, 500. Close the parentheses. Division, another division gets this division. That we have two divisions, no, this division, and this division gets completely outside the parentheses, 10. Divided by 10. Okay, yeah, get the answer. Okay, the answer is, I want to copy here, the thing I try to see in the display is 0.02004 A6. Not necessarily in every calculator, the electronic processor inside the calculator give me exactly the same decimal place and maybe doesn't match very well with the some digit, but this is approximately, right? You get this answer or no? Everyone get this answer or no? Yes, Sergio. Who more? Who have problem to get that answer? Jonathan, yes. In your own calculator, guy, in your own calculator. Maybe T, okay, good, perfect. Entonces, this is not a final answer. This is a partial answer because we need K. Remember, K is the growth rate parameter. Okay, entonces you store this partial answer inside the memory. Okay, so I press the key stores. I try to store in the memory A. Press enter. In this moment, in the display, I can see something like that. Answer. The answer is this number. Answer. Arrow A. And you press enter one more time. No, not necessarily press enter. Already stores. So when you call A is this weird number. 0.02004. Okay, so let's move on to the last part. The last part is compute the time. We're using the same formula, but the order is different. It's population at 30 days, que es 1 month, is equal initial population, que es 500, P null, exponential, K, que I have K in the memory, A, no? So actually, in my calculator, let me, well, K times 30. K times 30. And the display of the calculator, I typing in that way. Let me try. 500. Multiplication. 500. Multiplication. After multiplication. Exponential. Exponential, guys, is in the same key of the natural logarithm, pero en blue color or yellow color, depending the calculator. You press second, this key, and you see something like that. E power parentheses. And inside the parentheses, you put A. How you typing A? Well, the memory A, you typing second, STO, enter, time 30. Time 30, que es 30 days. And close the parenthesis. And press enter. Bang. Okay, this is you don't see very well in your calculator. Okay, but basically it's A time 30. But that part you don't see in the calculator. Well, at least in the TI 30X and the TI 83, yes, you see the process perfectly. Entonces the answer I get in my calculator is 912.396524. Okay, entonces you maybe in the problem specification you round, or si no specification, entonces you using the majority of the problem in the homework online y in the test online specification the amount of decimal place que they want. However, in the real life, nobody specification, but we are talking about inset, and inset have no decimal, and you delete completely that part. Answer is 912 inset. Any question, guys? Any question? What part is confusing? What part you are stuck? 2-step. The problem have 2-step. The sketch, I don't know, I lie. If you don't lie, it's okay. Because the sketch give me information, how many conditions we have, no? Because sometimes we have only one condition or two conditions, not three conditions, depending the problem, depending the information that's given at the beginning, no? Any question, any question? It's clear or confusing? Come on, guys. Rosalinda. Okay, okay. Clear, okay, clear. Everyone say get clear? I don't want to rush, we have time, because my plan is start Thursday, we start the review, no? And we spend Thursday and Tuesday next week. So the Tuesday I send the test number 4. Any problem? Let's see, I don't know. We select the best option for us. Okay, entonces everyone, okay, let me try to do one more problem similar. But in this case, it's easy. I bring this problem for the question that you asked me about the homework, no? Some students frequently ask me question, not only your class, another class of the college algebra that I teach in the morning. Suppose, this is the example 2, let me call example 2. Well, no, it doesn't matter the number. Suppose that the number of bacteria is in certain population increasing according to exponential growth. Model. This is the one kind of model. So the model is this equation. P of any time is equal to P null e to the KT. This is the name of this model. Mathematical model is now period. Example of 2500 is select from the population, from this population. And reach the size of 2,636 in 2 hours. Wow. Entonces the question is different. The question is find the hourly growth rate parameter. Entonces easy. They don't care how many bacteria. They care K. K is the hourly because the time is measured in hour. And this, so some problem, the time is measured in minute, in second, in day, in year, in century, or in hours. Okay. In this case, hourly growth rate parameter. K. Okay. They want to find K. So I use my famous formula. My famous formula is population to any time. Population to any time is P null, initial population, e to the KT. It's my mathematical model. Now, P null is, what is P null in your opinion? Opinion, help me. Please. What is your P null? 2500. Very well. This is 2500. Okay, entonces in my equation, 2500 is P null. Who is P at any time? At arbitrary time, is given in the problem. What is this guy? P, what is exactly? 2,636 is this guy. And this occur at 2 hours. So exponential K times 2. This 2 is 2 hours. Entonces you find K and end the story. And end the story. Okay, entonces we have one more time exponential equation. You divide both sides by 2500, no? We have exponential 2K. Okay, much better writing that way. Okay. Super. It's the answer. Jordan. Pero wait. 1 second. You apply logarithm both sides. Boom. Logarithm both sides. And when you apply logarithm both sides, you know que logarithm natural and exponential, both natural, cancel out as 2K. Therefore, K alone is equal natural logarithm of 2636 divided by 2500 divided by 2. And Jordan put in your calculator and his calculator, and the answer was 2.64859424. Correct me if I make a mistake. Let me see. In the chat again. In the chat. Let me see in the chat. I don't see the chat. Okay. But I don't know why in the problem, they want que you express it in percentage and also round. 0 point. Okay. Super. Same answer, yeah. But in the number that you type in inside the box in the homework online, it's not this. Yes, it's this. Okay, sorry, coño. Wait a second. I make a mistake. This is, look, the computation of this is equal 0.0, 26485924. But it's in decimal. But they want percentage. The percentage is easy. You multiply by 100. And they want you express the answer using 2 decimal place, only 2 decimal place. So when you multiply by 100, the decimal place moves 1 and 2. So actually it's 2.648594. And you express it. Very well. You truncate no round. 2 decimal place, this digit is greater than 5. You increase it, 2.65 percentage. End the story. And the answer of K. Remember, K is the growth rate parameter. Okay, give me information somehow about the what family of the exponential, because we have different exponential, no? But specific, I want this case for K equal this number. Okay. Everyone get the answer? Honestly, you feel strong in the calculator? You feel strong in the exponential and logarithmic? Okay. Sure. Strong. Like a ball. Okay. Let's see another kind of problem. Que is not completely different, but it's different. It's exponential, but decay. But let me explain the theoretical part first. Exponential decay. Exponential decay. It's the same formula, but using different letter. I understand why, but I don't want to explain now. Is for example, we have one technique using in archaeology to determine the age of the one antique object that the archaeology found in the excavation of the different place. Okay, you try to find carbon 14. Carbon 14 is a chemical element. Carbon 14. Carbon 14 is radioactive isotope. And I suppose this is the time in this case in years, because you need to find this, for example, this piece of the metal or wood, what is the age? Entonces, century or 1,000 years. Entonces, at the beginning, at t equals 0, when this situation happened in the history, suppose 14,000 before Christ, so the amount of substance of the carbon 14 is 100%. Okay, but this is the isotope radioactive and decompose. During the time, the amount of substance that we have decreasing, but decreasing exponentially, like that. And the formula is amount of substance. A, capital A represents amount of substance here, this axis. Amount of substance to any time is equal A null, que es the initial, que we can express in percentage, 100 or in gram or milligram. But okay, in percentage, and this problem was percentage, e to the kt. Well, professor, I don't understand one because this model is very, very similar. What is the reason que now decreasing? The reason is clear. Because the reason is because the rate is the rate, not growth rate, it's decay rate. And wait, how do you know, professor? Because K is negative. When the K is negative, it's decay. When the K is positive, it's growth. And you see in the problem now, when you compute the K is negative. Okay? Entonces, okay, sorry. Entonces, in that moment, que I found this object, this is t equals 0 represent 10,000 before Christ. And this is today. But I need to find accurate. Si it's 10,000 or 14,000 or 20,000. So I need to investigate mathematically the approximation for this time. So I need to find time, basically, time. Okay, entonces, to find that, the chemistry, the people who study the chemistry define one thing is called half-life. What means half-life? Well, it's the time. Suppose half-life is when the 50%, half of the 150, and this is given. So each radioactive isotope, because there are several, not only for carbon 14, have a specific half-life. The half-life for the carbon 14 is 5,600 years. However, I don't know exactly. This is this time, 5,600 years. But this is bigger, I suppose, no? No, depending on percentage. Suppose you have 2% or 1% in this moment. So I can take the sample of the carbon or the object and use the instrument analysis spectrum. I can determine the amount of carbon 14 we have, and we mathematical using logarithm and exponential compute the age of this. This is the basic idea. Look, the problem say trace of burned wood along with the ancient stone tools, maybe hammer, were found to contain approximately 1.67% of the original amount of carbon 14. If the half-life of the carbon 14 is 5,600 years, approximately, when was the tree cut and burned? Okay, it's a typical exponential decay problem. The formula is amount of substance anytime is equal A null, is the initial, e to the KT. Y I know que K is negative because I know que it's decay problem. Our problem talk about percentage. The initial A null is not actually given, but I suppose que 100. Okay, when you have completed the material, no decompose, no disintegration. Entonces es here is 100%. E to the KT. And this is 1.67%. No. This is completely wrong. Completely wrong. Okay. First of all, I need to find K. Let me do the sketch to understand. No algebras. No algebra. Okay. The sketch is, look. Again, we have this situation. Time, amount of substance. At the beginning, we have 100%. This at t equals 0. It's decreasing like that. I take the sample. In this moment, it's 1.67%. I need to find this time. I don't know how many years. However, I know that the half-life of the carbon-14 is 5,600 years. At 50%, get the half-life. This time is 56 years. Then we have condition 0 again. Condition 1 can allow us to find the K for the half-life. And finally, condition 2. And the condition amount of substance, and you find the time. It's a little bit different to the another problem. I change, no, to illustrate the potential of this technique. Okay, so let's go to the condition 1. Condition 0 is amount of substance to any time is equal 100, actually percentage, e to the kt. Okay, this is the transformation for the equation using the condition 0. Using the condition 1, entonces 50 here, 50% is equal 100%. A to the k multiplication by 5,600 years. Entonces, in this moment, I have one exponential equation in which the only unknown is k. Solve for k. Okay, let's do it. Divided by 100, both sides. Everything is canceled. This is 1/2. It's obvious, right? A to the k times 5,600. Now you apply logarithm. What kind of logarithm is most convenient? Natural, of course. Natural logarithm 1/2 is equal. This is natural. I don't repeat again a stupid idea. 5,600 k. Therefore, k is equal natural logarithm 1/2 divided by 5,600. Okay, pay attention now. Before using the calculator. No. Everyone pay attention. Remember that when you compute the logarithm of the number less than 1, in this case, 1/2 or 0.5, you want to put 1/2, is negative. It's negative. And make it sense it gets negative because it's exponential decay. Okay? Now, this is the moment. Everyone help me with the calculator. Calculator. This is the display of the calculator. You put in the display of the calculator ln 1/2 division 5,600. I try this. Natural logarithm 1 division 2. Close the parentheses. Don't forget to close the parentheses. Division 5,600. Bang. I get, depending the, this is the answer, Flora. It's negative 0.00030, no? 1, 2, 3, 7, 7, 6. Another calculator maybe expresses the answer using scientific notation, but it's the same. It's the same. And TI 30x express it like that. And TI 83, let me try in 83. And 83 is, you see.
Yeah, I did it. I got it.
Yeah, but in scientific notation or in decimal?
In decimal, I got it completely different.
Okay. Super.
I'm probably doing something wrong though. Do I
depending the setup, the setup. For example, in my calculator, I get this answer. Look, 1.2377. It's the same, no? 6, 2, 8, 2, e to the minus 4. What mean that? It means 1.237 blah, 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 times 10 to the negative 4 power. It's scientific notation. Depending the setup of my calculator, because you can change the mode. But no, it's not important now. Okay? Okay, this answer and this answer are perfectly equivalent. And you store, please, this partial answer, because this is not the final answer. The final answer I want is how many years have this hammer I found for the before Christ. So you store, remember the store key, STO. We're using the same memory, A, press enter, boom, that's it. Actually, I have in the memory. This value I have in the memory A. Memory A store this number. Okay, what is the second step? Well, the second step is come back again to the formula. Come back again to the formula. But in the formula I have the percentage. Look at that. I have the percentage, que 1.67. This is a moment to using this percentage, que the analyzer spectrum give me 1.67%. This represents 8 to any time. But the problem is that I am looking for the time 100 exponential KT. Okay, you solve for T now. Solve for T. The T you don't know. Okay, entonces es divide both sides by 100. Apply natural logarithm again. Natural logarithm 1.67 over 100 is equal KT. Because when you apply natural logarithm and exponential cancel out, and this is cancel out, KT only. Therefore, T, que es my goal, is 1.67 over 100 divided by K. K I have in my memory of the calculator and the memory A. So in the display of the calculator, you type in something like that. ln of 1.67 divided by 100, close the parentheses. Close the parentheses, division. Division what? Division A. So you press, where I can find A? In the memory. And the memory is second STO, where you select A. And you press enter. Boom. Boom. You press STO, select A, division, no, division. I forgot division. And you get this number, you don't see very well the process, and you press enter, and you get, what answer you get, guys? I get a weird answer here. What is the answer? Yes, you are right. The answer is 33,062.44529. Suppose que I don't want it. Yeah. Pero suppose que one round a little bit. Entonces es obvio que es 33,000 before Christ, 62 years. Is the age of this object. Is the age of this object. Okay. And the homework, I get another problem. Any question, guy? Because I am exciting. Entonces, thought maybe one student have a question, no? No? Do you follow me? You have no problem with the algebra, with the manipulation for the calculator? Okay. Another problem similar que I saw in some homework. Remember, the homework is different for every student. Okay, is this problem case is talking about the same idea. It's a radioactive substance, a radioactive substance that decay according of the exponential decay. And the formula is given the formula. Y is equal Y null into the negative 0.053t. Actually, they give me the K value, no? The K value is negative. Flora dice, K, professor. So actually, I understand, according to this information, que K is equal to negative 0.53, and in confirmation, que es negative, entonces es de K. Super. They want to know, find the half-life of the substance. So they want you find half-life. Okay, let me try. Half-life, remember, means que the amount of substance, Y, is Y null divided by 2, so 50%. Entonces I need to do something in order to solve for T, que es the half-life. Es the half-life because specific, my supposition is que es the half of substance. The Y null is cancelled and stay 1/2 equal exponential negative 0.053t. Apply logarithm both sides. Apply logarithm both sides. We have ln 1/2. Okay, suppose que this give me a negative number. Is equal minus 0.53. 0.53t. And solve for t, que es the half-life in this case. Entonces, ln 1/2 divided by negative 0.053. Don't worry, because I know okay, natural logarithm 1/2 is negative, and negative divided by negative is positive. And the answer should be positive, no? Because the time. Please put in the calculator this. Now calculate. Calculator moment. Calculator moment. Nobody? Remember something. Any calculator has to. Exactly. That's the answer. The answer is exactly. The answer is 13.07824.869. But they want que you round to the near two decimal place. Tum tum. This digit is bigger than 5. Therefore, the answer is 13.08. Important, guy. The unit is hours because the problem measure the time hour. This problem, another problem is year, another problem is minute, another problem is second, another problem is millisecond. But in this case,
Professor,
please.
make it small so I can take a screenshot.
Yeah, of course. It's okay, miss.
Yes.
Okay, super.
Got it. Thank you.
Another problem. Yeah, the last
Professor, I have a
problem.
quick question.
Please, go ahead.
So when the variables, when it's y or y, the NO or whatever to the e, it's all the same formula, it's just with different variables. That's what threw me off.
Normally, I call amount of substance A to any time is equal
Okay.
A null in each. But this I call Y. I don't know why.
Okay.
I don't understand. I don't understand very well the reason. Pero this it doesn't matter why variable.
Okay.
Okay. Let's move on to the last problem, que es super interesting. Que es about Newton, a famous physics, cooling law. Let me explain the idea behind Newton cooling law, and let's see the formula applied directly to the example. Okay, suppose que we have one object que es very hot. Suppose, I don't know, 100. No, 100, no, 400 Fahrenheit degree. Suppose que es a pizza, right? Pizza Hut, right? And you put a pizza on the table, and you can leave, and you right back tomorrow in the morning. So my question is, what is the temperature of the pizza tomorrow? This is now. Tomorrow in the morning, same pizza. The temperature is the environment temperature. No, suppose que we have air conditioner and I put it in 70 Fahrenheit degree. Okay, this is the cooling process. And the cooling process, so we have initial temperature, initial. TI is initial. And this is the final temperature. It is the temperature of the environment, of the room, temperature room. And the mathematical law of this process is like that. Look, let me show you. This is the time, maybe in hours or in minutes, depending on the problem. The initial temperature at T equals 0 is 400 Fahrenheit degree. That is